Hello everyone, my name is Sentio Joshua and I'll be presenting to you the Sentio system. Now, Sentio right here is a Latin word which means to feel, and that is exactly what our system does. It feels. What does it feel? It feels music and is able to classify it into its categorical emotional makeups. So let's get started and see how this system works. So the core problem today with recommendation systems of music is that they overlook the core uh, thing that music enthusiasts actually focus on. The systems today are based on genre, title, artist. These are the things that they base on, and they are not enough or they are irrelevant for the recommendations. People relate to music on an emotional level. And then the other problem is that there's scarce data for African songs that are annotated in terms of emotions. So the system also tries to expand on that and create systems that are balanced in such a way that every culture, especially Uganda, is accounted for in terms of annotation. And then there is also this it works on solving the two sustainable development goals, that is goal number 3 for health well-being, because it provides music to people in a categorized way emotionally, so that people can easily choose music that best fits to their emotional needs. All right. And then 10, it reduces inequalities for cultural access because it is trying to balance the annotation of data, especially for resource constrained areas like Uganda. So the stakeholders are anyone who is interested in music. If you are a music enthusiast, this system is for you. People who use mental health or therapy applications like Headspace. Headspace is a very popular therapy application. You would find this system also very useful to you. DJs, event planners, radio presenters, someone who relates to people but through music, they would also need this system. It would be very beneficial to them. And then why AI? Why do we choose AI as our solution? Well, as I've said earlier, we cannot just based on genre-based rules to provide the best recommendations. Why? Emotions are complex. AI on the other hand works in this multidimensional space whereby it's able to relate different features in music in this space where it's so large and has vectors pointing in different directions, and then can map different can train and also learn to map different music features to the right and appropriate emotions. Now, this system is aimed at boosting the engagement of already existing systems like Spotify. You can talk of Tidal, where people go to listen to music. But now, because someone can really like it to have a system that they can visit, and then they can have playlists already categorized by emotions. There's sad, there's happy here, there's excited there, and engagement of the site increases, and hence therefore the revenue also increases. And this also works on the 9th sustainable development goal, which is an innovation of already existing infrastructure. So the primary actors, I've talked of those earlier. Maybe let me touch on the governance. So we'd have to stay within the bounds of the National Information Technology Authority, that is NITA, and also the PDPO, Personal Data Protection Office. So the data sources, our system here uses audio files input, and anything that can be turned from an audio file into some other input, like mail spectrograms. The source of our data set was the University of Geneva with its 1,800 songs. But then we were able to update the number of spectrograms using our SIGAN, and that is a core part of our pipeline. So we got our data from the open data sources. We cleaned that data, we validated it, we trained our models on it, we distilled and compressed and then stored the models. And then for the solutions, so our model right here is a vision transformer, and it inputs songs or spectrograms Then it predicts the emotions. It categorizes, classifies the emotional makeup of the song. So the architecture pipeline over here is the mail spectrogram extraction into the SIGAN, which is the conditional generative adversarial network, and then for expansion of the data set, because it is limited, but then we can expand on it. Then we can train the model, distill it, and then have a model that can run on a mobile application, a mobile phone. Yes. So we integrate this or deploy this in form of a render. Render has the back end model running, and then we have the front end with Vercel, and then the two communicate over fast API networks so that they can share information, and then the users can access that on their Chrome browsers. So let me talk about the business over here. So we acquire customers through a freemium tier subscription, like 5,000 per week for the mobile application, and then someone could pay 50,000 for a lifetime value of this offline model, the mobile application, through our telecommunication partners. So the unfair advantage we have here is that we were able to get a data set of emotion annotated by experts. That is good for us. And then we also have the SIGAN system we incorporated so that we expand on this system. Yes, the SIGAN was able to create more synthesized spectrograms by learning from the original data in the data set. Now, we also have a specialized transformer, the Google VIT model, that was already trained on a large backbone of images. So we pre-trained it to allow it to be able to also learn from spectrograms and determine the emotional makeup of a song. Strategic partners here are the African telecommunication operators like MTN, Airtel, and then also the cultural organizations like UNCC, and that is the Ghana National Cultural Community or Council. Then our channel of distribution, we shall have hackathons from various universities so that students can get acquainted with our system, and then also organizations like the MHU and UNICEF, and then we shall have also webinars and also API docs so that developers can learn how to operate with us, work with our system APIs. Then we deliver this as a mobile application that's for offline usage, and then we can also have a software as a service whereby someone can access it as a web application or API calls. Alright, so then the revenue streams for the freemium tier, I've talked about that, that's the offline model. Then for software as a service model subscriptions, we would have large companies that would like to integrate this in their already existing systems, pay a monthly fee of 500 per month, and licensing would be like 100 shillings per API query that is made to the system. Alright. So the key resources are the humans, the infrastructure, the data, the organization, and the finance. For the humans, a team of 5 would actually be good enough to keep the business model running. That would be AI engineers over here, and then machine learning researchers there, data scientists, designers, and then importantly the ethicist, who is working on the cultural biases, checking that the system is not biased in any way. Then the infrastructure would have a hybrid of cloud and also dockerizing this system so that it is able to scale. And then we shall have machine learning flows like Grafana for monitoring and all that. For the data, a community of volunteers or people, experts, who would be paid to annotate the already existing Ugandan songs so that we can add that to our DIM dataset and expand on it with time. Then for the finance, seed grants from the Uganda Ministry, ICT Ministry, would also be very helpful in helping out on the system growth. So for the governance and compliance, I will talk of the biannual AI audit. So we need to stay within the bounds provided by organizations like the UDP Act, the Uganda Data Protection Act, and then also the UNESCO AI Ethics. We shall also be customer focused in such a way that there's technical support for our end users on forums and also site. So the technology partners for the hosting, Google Cloud would be very good. Also the Makerere University AI Lab providing research and development so that we transfer this and amplify the innovation of the system. The distribution partners, I've talked of MTN, the telecommunication networks already. That's for the offline usage of our application. and then strategic collaborators like MHU, Mental Health Uganda, then UNICEF. Uh, so the cost, this is a very important part of this. What would be the cost of such a system? For the data costs, would have 20 million paid annually for community collection of annotation of Ugandan datasets. Then 8 million for labeling. That would be about 500 Ugandan shillings for each song that an individual is able to annotate dynamically for its values and arrays of values. Then for the computer and infrastructure, like 2,000 Ugandan shillings per hour for the A100 GPU chips for the training and also scaling of the system. For the human resource, for the 5 people I've talked about earlier, total salary of 180 million annually for all the 5 categories: the AI engineer, the user experience designers, the ethicist, all those people. Then 10 million for staying within the legal bounds of compliance with the legal stuff. That would be 10 million. And then marketing, so that this system gets out there. 20 million for the hackathons, for the expos. That would be good money, yes, to expand and also let people know about the system. Then 25 million annually for continuous maintenance and retraining of the system, so that it keeps on optimized and maintained very well. So for the accountability, we would get feedback channels from users and also correct emotional predictions with community review boards. Let me talk of the scalability. So would use microarchitectures and Dockerization. I've talked about this, so that we have these spectrograms. That's our workflow: the spectrograms, SIGAN, VIT distillation, and 30% of the money that would gain from the subscriptions would be injected back into the system for the continued sustainability of the business model. Then for the resilience, we'd use the backups and offline model fallbacks, so that the system is always on a 99% degree that it is always up and available for the end users. Our intellectual property is the innovation, and innovation is the pipeline process that we use to create this model. We get the mass spectrograms, the SIGAN, which is actually a core part of getting this system up and running, because it helped on expansion of this data set and enabling the system learn better. And also in the future, the data set that we shall collect by the experts that will annotate the Ugandan songs will also become part of our intellectual property that we shall serve out to the world for a fee. Then these are contributions from the individuals that made this system possible: the lead AI architecture and model engineer who designed the end-to-end transformer pipeline, which is our intellectual property over there, and then the data and generative systems lead who worked with the SIGAN and also collecting, cleaning, and augmentation of the data. And finally, the user experience and deployment strategist who developed the mobile application, the web interface, and deployment on Vercel and Render. And also we thank our supervisor, Mr. Kaliwango, for the good supervision that he provided to us. And with that, I would like to stop here and thank you for listening.